Okay. So before we talked about functions and then we talked about graphing functions, today we're going to talk about properties. Some of you may have already heard some of this stuff. We're going to talk about minimums, maximums, odds and evens, all that, okay? So to start with, I'm going to read you the definition. It's going to sound like a foreign language because even as a math person, some of these definitions sound like a foreign language. And then I'm going to tell you the easy way to decipher them, okay? So first off, we start with a definition of an even function. And it says for every number x in its domain, there is a negative x also in the domain where f of negative x and f of x are equal to each other. Equivalently, the function of f is even if and only if whenever the point xy is on the graph, the point negative xy is also on the graph. So, f of negative x is equal to f of x. So those two things will be equal to each other. An easy way to think about this is it will be even and this is an example of an even graph or an even function. So it's going to look the same. Looks the same, sorry. If we fold at the y-axis. So basically, if your y-axis is a line of symmetry, then it will be an even graph, an even function. It will be an odd function if, when you plug in the negative x, you get negative f of x. So all of the signs will change in your function. And I'm going to show you what this looks like, so just hang tight. So these are examples. So this one will look the same if you rotate around the origin. Think of a spin. All right, so just looking at a picture, you can determine if it's even, if it's odd, or if it's neither. So if you look at this first one, if I fold it along the y-axis, if that is my axis of symmetry, I can fold it and it will match up point for point. So this is an even function. I can fold it in half. This next one, I can spin it upside down. So this one I can spin upside down. And it's going to be the same. So this one is considered odd. Because I can't fold it, so it's definitely not even. So then we check if we can spin it. And then this next one, if I were to fold it along the y-axis, it's not going to match up point for point. If I spin it upside down, it's not going to be the same. So this one is neither. So that is a way to look at them and tell if they're odd or even or neither. All right. Now, if we identify them, what you do is you take the function and you replace all the x's with negative x's instead. Parentheses are crucial. Do not leave them off. Okay? So what you're going to do is you're going to take f of negative x. So you're going to have negative x squared minus 5. Well, when you take negative x and you square it, because think about what negative x means. It means negative x times negative x, which is positive. So this becomes x squared minus 5. And what I see is I started with x squared minus 5, and I ended with x squared minus 5. So since they're exactly the same, this is even. So this is an even function. Questions? All right. So let's try it on this next one. So now we're going to replace the x's with negative x's. So we get 6 times negative x cubed minus 2 times negative x. So think about negative x, negative x, negative x. Is your answer negative or positive? It's negative. So this term right here becomes negative 6x cubed. And then negative 2 times negative x is positive 2x. So then go back. You started with 6x cubed minus 2x. You ended with negative 6x cubed plus 2x. So do you see how the signs completely changed on every term? That makes it odd. So what happened, just to kind of, over here to the side, I'm going to show you, if you were to take your given function, 6x cubed minus 2x, if you were to multiply it by a negative, you would get negative 6x cubed plus 2x, which is what we ended up with. That's why it says g of negative x is equal to negative g of x. So basically the negative goes from being in front of the x to in front of the whole function. And that happens when you have odd exponents because it gives you negatives. All right, let's look at the next one where we have the odd exponents here. So we're going to take h of negative x. So that's going to be 8 negative x to the 5th minus negative x cubed plus 4. So I know this negative x to the 5th is going to stay negative x. So I'm going to bring the negative out front. So that's negative 8 x to the 5th. The negative x cubed is going to stay negative, but there's already a negative out front, so that's going to become positive x cubed, and then the plus 4. So now go back and look. We started with positive, negative, positive. Now we got negative, positive, positive. Did all of the signs change? Then this one is neither. All of the signs have to change for it to be odd. If they all change but one, it's neither. All right. And then the next one we have q of negative x. So you got negative x to the 8th plus 8 negative x squared minus 13. So the negative x to the 8th becomes positive because you have an even number of negatives. So that is negative x to the 8th. This negative here will come down. This negative canceled out. Plus x squared, so 8x squared minus 13. So look at what you have. We started with negative, positive, negative. We ended with negative, positive, negative. So this one is even. All right. So now let's look at the next part. The next part is talking about increasing and decreasing or being constant. Well, it means exactly what it says. You're increasing, you're going up, you're decreasing, you're going down, you're constant, you remain the same. You're going straight across. And it's looked at in intervals. So you have increasing between these two x values. You have decreasing between these two x values. You're constant between these other x values. So this is all looking at x values. Okay, it's kind of like looking at the domain. Okay, so if you look at, oops, let's not do that. So if you look at this graph to determine whether function is increasing, decreasing, or constant. So think of tracing the graph starting at the left and tracing it around to the right. So if you trace it from left to right. So trace your graph from left to right. And your answers will all be x intervals. So answers will be x-axis intervals. So you'll start at an x value and you'll end at an x value. So starting at the leftmost part of the graph, the very first from here to this point here, that is decreasing because we're going down. And then from this point up, we're increasing. And from this point forward, it's constant. And then we start decreasing again. So if you're thinking of tracing it. So where is it increasing? So it's increasing from this point to this point. So that is from -4 to 0 is where it is increasing. Where is it decreasing? Well, it's decreasing in two different places because I got the two decreasing in green. So from -6 to -4, and from 3 to infinity. Because that arrow says this one is going to keep going. And where does it remain constant? From 0 to 3. And that's how you determine your intervals. Look at it from left to right, and then mark your answers as X's. Questions? All right. Well, let's look at this first one. So where are we increasing? Where are we decreasing? So I know right here is where I go. So I start from this leftmost, and I'm increasing. So from -infinity to -1, I am increasing. And then I start going back down. So from -1 to +infinity, I am going back down. So this would be the decreasing part. And I am not constant anywhere, so there are none. All right, and the next one, there's my break right here. So from negative infinity to -1, I am increasing. I'm never going down, so there's none for decreasing, but I am remaining constant from -1 to positive infinity. So this is an increase, this is constant. An increase, a decrease. Questions? All right, so let's look at the next two. So sometimes you'll have lots of hills and valleys too. All right, so increasing. So where am I increasing? Well, first I'm going to identify all the points where things start to turn. So I know from negative infinity, I'm decreasing. So from negative infinity to -3, I'm decreasing. And then I start to increase. So from -3 to 0, I'm increasing. Then I start going back down again. So from 0 to 3, I go decreasing again. Then I start coming back up. So from 3 to positive infinity is my next interval of increasing. And there is none where I am constant. Questions? I will tell you, I'm going to have you enter your homework assignment. Will be on paper, which you'll do all your work. But I am having you enter it into a form online so that it can get graded quicker, because I'm trying to grade all your papers. And I feel like I'm taking too long to get them back to you. So when you enter this online, for infinity, you'll just put INF. And for negative infinity will be negative INF. Does that make sense? Because it doesn't have a symbol for infinity on this format. So we're just going to use INF for infinity. Okay? All right. This next one doesn't have any infinities because it has the solid circles here. So I am increasing from -5 to -4. I am decreasing from -4 to -2. And then I start increasing again, so from -2 to 0. And then I go down from 0 to 2. I increase again from 2 to 4. And then I come back down from 4 to 5. And there are no constants. Questions? Are you guys feeling okay? All right. We're halfway through. All right. Relative minimum and maximums. Basically, the difference between a relative minimum and maximum, and an absolute minimum and maximum. Absolute is the absolute highest or lowest point on your graph, and the relative minimum and maximums are your dips and your valleys that fall in between. Okay, these are all looking at y values. So now you're kind of looking at the numbers that fall along the range. Are you with me? All right. So if we were to just look at, I don't know why it does that. If we were to look at this graph right here, if you're looking at your y values, does this function have an absolute maximum? Well, the first thing I notice is that it's got these arrows, which mean that the absolute maximum would keep going on for infinity, right? But you cannot use infinity when you're talking about maximums. So this one would be, there are none, because you cannot be infinite. So if you notice that your minimum or maximum is infinity, then that means there are none. All right? Now, if you're talking about it being an interval, you can use infinity on your intervals, but not on your maximums and minimums. Does this graph have an absolute minimum? What is the absolute lowest point I can go on this graph? Well, it goes along this line, which would be y equals 0. And when it asks you if it has any relative maximums, the relative maximums are the top of a hill, okay? So if I look at this, if I trace this out, I come to a top of a hill right here. So that would be 1, 2. So you're actually looking at y values, you're looking at points. And then a relative minimum, well, relative minimum would be negative 1, 1, because it goes down into a dip, and 3, 0 is another dip. So you're fixing to put some information in this little blank spot here in the lower left corner, all right? So this will help you. So an absolute maximum, this is the biggest or highest y value for the function. So the biggest or highest, however you want to look at it, y value for the function. And an absolute minimum is just the opposite. It is the smallest or lowest y value for the function. So these answers will be in the form of y equals. And then the next part is your relative max. This is the top of a hill. And a relative minimum. Which is the bottom of a dip. Oops, wrong way. So it would look something like that. So now let's look at some examples of finding our absolute max and mins and our relatives. Yeah. So looking at this first graph, these two are going to be in the form of y equals. These two will be in the form of x, y. So what is the absolute maximum of our grid? Well, it looks like this point would be the absolute maximum, doesn't it? Except I notice as I trace this out that this has an arrow. So if infinity looks like my answer, then the answer is none, because we cannot use infinity to describe a maximum. Now, what is the absolute lowest point that this graph goes? So y equals 0. And now, are there any tops of hills? Do we have any tops of hills? So 0, 5 is the top of a hill. So top of a hill. And do we have any lower minimums? The bottom of our dips would be 4, 0. So you're looking for tops of hills and bottoms of dips. Questions? Easy peasy. All right, let's look at the next one. Do we have an absolute maximum? What is the absolute highest point of this graph? So y equals 2. Is there a minimum? Why not? Because it goes for infinite, so there are none. These little arrows tell me that this thing is going to keep going. All right. Are there any tops of hills? Do we have any tops of hills? This is the top of a hill, so 0, 2. This is the top of a hill. That's 2, 2. And our relative minimum, our dips, would be 1, 1. Questions? Okay. Is it okay to scroll yet? All right. Absolute maximum. What is the absolute maximum value that this function can be? So the very tippy top of this is y equals 5. And there are no arrows because we have points. So this one has a minimum. And the lowest that this can be is y equals -4. Do we have any relative maximums? Are there tops of hills? Well, this is the top of a hill. So 0, 5 is the top of a hill. There are no dips, so there are no relative minimums. All right, last one. We have this arrow that goes on, so that tells me there are not any absolute maximums. There is a point on the end here, so this is the lowest point, so this is y equals 0. There are no hills, and there are no dips. Questions? All right. Last one. Please tell me that you remember the term rate of change. Slope is your rate of change. So we are looking for the average rate of change for any function. And you're doing it between intervals, okay? So think about the slope formula. All right, so remember rate of change is slope. So you're just looking for the average slope. So the way you have to do it is they're going to give you an A and a B. So from this point to this point, right? And you're going to plug them into the actual function, and you're going to find the answers to those functions. Then that is going to be the change in your y value. That'll be the rise part. And then you subtract the numbers they actually give you, and that's going to be your run. So, first thing we're going to do, this is the function we're going to use for all of our examples. We're using the same function. We're going to look at the average rate of change between two values. The first is 0. So I'm going to find f of 0. So I'm going to replace all of my x's with zeros. Well, 0 squared is 0. 0 times 2 is 0. 0 minus 0 is still 0. And then I'm going to find out, well, what is it when I plug in a 1? 2 times 1 squared minus 3 times 1. Well, 1 squared is 1, and 1 times 2 is 2. 3 times 1 is 3. So that's -1. So to get your average rate of change, you plug it into this formula. So f of b is -1 minus f of a, which was 0. B was this +1, and our a is 0. So you got -1 divided by 1, which is -1. So the average rate of change between 0 and 1 is -1. Questions? All right, so let's try it again. Now we're going to look at the interval between 0 and 4. So we already know f of 0 because we just did it. It's still 0. It's not going to change because we're still using the same function. But now we're going to find out what is f of 4. So 2 times 4 squared minus 3 times 4. So this is 2 times 16 minus 12. 32 minus 12 is 20. So now take these numbers and plug them into the formula. F of b is 20 minus f of a is 0. B is 4, a is 0. So 20 divided by 4 is 5. So your average rate of change between those two intervals is 5. All right, last part. Same function. So we're going to look at the function when x is 2. So 2 times 2 squared minus 3 times 2. 2 times 4 minus 6. 8 minus 6 is 2. And f of 6. 2 times 6 squared minus 3 times 6. 2 times 36 minus 18. 72 minus 18 is 54. I'm sorry, it blocked that. Okay. So now to find the rate of change. F of b is 54 minus f of a is 2. B is 6, a is 2. So this is 52 over 4, which is 13. So your average rate of change is 13. And that's it. Okay, it is a pattern, a formula. You plug it in, and you find your slope between those intervals. The end.